boys and girls, my name is Miss Connolly. I started making videos for my students and this one is for them, but I wanted to make sure I shared with all of you so we could keep as many students learning as possible during this crazy time. If you have any questions or topics you want me to cover, please reach out to connollymathathome@gmail.com and I can make you a new video or answer any questions you might have. Okay, so let's get started. Today for math time, we are going to think about multiplying a fraction by a whole number. Okay, we've done this before and we've used repeated addition because we know when we're multiplying it's really repeated addition. But today we're going to be working with much larger numbers where repeated addition doesn't necessarily make sense. So I'm going to start us off with some whole numbers just to remind you what you know about multiplying. Okay, I'm going to pick some numbers we're super familiar with. So let's start with 2 times 100. And I have a very important reminder for you, okay? The multiplication symbol stands for groups of, okay? So one way to read it is 2 times 100. The other way to read it is 2 groups of 100, okay? So for today's work, we're going to be using what we call a fraction bar representation. So let me show you what that's going to look like. So when we are representing the whole here, so 100, let's give a story problem context. If somebody was doing a 100-meter race and they do that 2 times, how many meters have they run altogether? So the whole entire race is 100 meters long and they're going to do that 2 times. So you can probably predict how many meters do they run altogether. So this fraction bar here is representing the whole. The whole race right now is 100 meters long, okay? They're gonna do that 2 times. So to show another whole that's the same exact size, I'm gonna write it underneath. This will be important in the next video when we do mixed numbers too, okay? So I have one fraction bar that represents 100, and then I have a second one that represents 100, and they did both of these. So they did 2 groups of 100, which you can see is 100 plus 100, and that's 200. Something I want to point out that happens with whole numbers is that we can multiply 2 times 100 and get 200, and 200, our product, is larger than both of these factors. But when we're multiplying by a number less than a whole, something different might be happening, and I want you to pay attention to that. Okay? So, the big question is, what happens when we change this whole number to a fraction and we're multiplying a fraction by a whole number? Let's find out. One thing I want you thinking about all the time is what will our products be? Will our products be greater than 100 or will it be less than 100? That's something we're going to talk about, what conjectures we can come up with for when we're multiplying by a fraction less than a whole, when we're multiplying by a number greater than a whole. Very important skill in 5th grade. So, anyways, when we read this, we're still thinking about this as 1/2 groups of 100. Okay? To make it simpler for us to understand, because saying a half of a group of 100, that makes sense. But let's just say half of 100. Okay, what is 1/2 of 100? And some of you might know this already because I picked super familiar numbers for us to work with at first, but let me show you a representation that we're going to use. So, like I said, I am going to use what we call a fraction bar. This purple marker right now is representing the entire bike race, 100 full miles, okay? So from here to here, this is 0, this is 100, okay? That is 100 full miles, and we learned this in class with the fraction bar, and you're going to remember it in just a second. So, I'll use a red marker today to show the fractional parts here. So, 1/2 of 100, I'm going to cut this fraction bar in half. Now, if the whole thing from here to here is 100 miles, and I split it into, as you know, 2 equal parts, how many miles is each part worth? So we can think about this a couple ways. We can think about what times 2 would get us to 100, or same thing, 2 times what would get us to 100. Or if you like to think about it as division, you can think about it as 100 divided by 2 equals what? So in each of these situations, I'm sure you've discovered, and you're like, why won't she just write it down, that each piece would be 50 miles, okay? So when we use a fraction bar representation, we want the numbers in here to add up to our total, which is 100. So let me just double check, 50 plus 50 is 100, good. We want to make sure we have the correct number of equal parts. Yes, I have 2 equal parts. And so then, to find our final answer here, what is half of 100? I'm going to circle my half of 100. Okay, so you'll see that 1/2 of 100 equals 50. And I'm using a story problem context. If there's a bike race that's 100 miles long and I biked half of it, how far have I gone so far? If I've gone 1/2 of a 100-mile race, so far I've gone 50 miles. Okay? So let me review what happened real quick. We used the fraction bar representation. We knew that the entire thing, the whole, was 100 miles. That's the whole race. Got to keep track of the whole. Then we said, how many equal pieces do I need? 2. And how many of those pieces have I traveled? 1. 1/2 of 100. So that's how I ended up with I've gone 50 miles so far from this representation. Okay, so let's try it with some numbers that we're not as familiar with, and we have to rely on the representation to help us. Okay? All right, so we'll stick with that bike race context, even though some of the miles might not seem realistic, but let's pretend that the bike race lasts 5 days, and each day you do a little bit of the bike race. Okay, so let's think about that. So let's say, I'm going to come up with a new distance for the bike race. Let's say that, oh, my hole is going to be in purple, that we have a race that is 240 miles long. Okay, so my fraction bar, the entire race from start to finish is going to represent 240 miles. Okay? And I am going to bike, let's just do 1/4 of 240. So, I know some of you at home are thinking, well, I could take half of 240 and then take half of that again. And there's several strategies to get at this, and I want you to explore those definitely. I'm going to go over using the fraction bar and thinking about fourths, but if you have another strategy you're thinking about, that's totally fine. Okay, so let's think about this. If I want to do 1/4 of 240 miles, first I have to think about how many equal parts would I be dividing my fraction bar into. So I look at my denominator. I know that there's 4, I'm dividing this into 4 equal parts, so I'm going to do that. Here's my 4 equal parts. And I'm thinking about what would each part equal if I took 240 miles and split it into 4 equal pieces. Okay, so if I took 4 equal pieces and I wanted to make 240 miles, I want to think about what's going on there. Some of you might be thinking about it as division, which is fine. Our goal right now is to figure out how many miles fit in each of these fourths, okay? And it has to be equal, because when we're talking about fractions, we're talking about equal parts. So what do we end up with in each box? And some of you might be thinking about your basic math facts, and you're thinking about, I know 4 times 6 is 24, so I know 4 times 60 is 240. If you weren't thinking about that, that's a little tip for you. So, I am going to label each fourth with 60 miles because I decided that 4 times 6 is 24, so I know 4 times 60 is 240. Okay, so now I think, and I double checked, 60, 120, 180, 240. Just want to make sure I didn't make any errors. And so now I want to figure out, if I go 1/4 of the way, how many miles have I gone so far? So in my representation, I am going to circle my 1/4. Okay, I hope that you notice, boys and girls, I am not shading anything. Okay, there is zero shading going on. This is a different representation. So I'm not asking you to draw a fraction bar, cut it into fourths, and shade 1/4. Okay, I am asking you to cut the fraction bar into 4 equal pieces and figure out how many miles each piece represents. It's very different, but please make sure that you're not going and just shading and saying you're done. All right, sorry, I noticed that mistake in the classroom. I want to make sure we don't make it today. All right, so when I circled 1/4, I'm thinking, what is 1/4 of 240? Well, here's my 1/4 of the 240. So I know that if I've gone 1/4 of 240, I have gone 60 miles. Now, interesting thing that's happening, I'm multiplying, and my product is less than this factor. And that's something I want you thinking about as the videos build this week. 1/4 of 240, and I'm multiplying and I'm getting a product that's less than this. That's not something we're used to with whole numbers. Why is that happening? Be thinking about that. All right, so I am going to keep this, I'm just going to redo my first fourth here, because I want us thinking about, what if I go more than 1/4? What if I go 3/4 of 240? So we already did a lot of this work. We said, I know I'm working with fourths, so I'm going to split my 240 into fourths, and I figured out what each fourth was worth. But a couple days have passed. I've done 3/4 of 240. So what do I do in this situation? Well, I'm going to use my representation to help me. If I know that 1/4 is 60 miles, I know that 3/4 is 3 groups of 60 miles. Okay, so after I've divided 240 into fourths, then I'm going to gather my 3/4, and that would be 60, 120, 180 miles. Okay, so just so you know, sometimes your numerator is going to be greater than 1, and you are going to have to figure out how many of the fractional parts that you split your whole into that you're going to have to take. So 3/4 of 240 is 180. Again, 180 is less than this factor. So something is happening when we multiply by a fraction less than a whole. And I want you to be thinking about that this week. Okay, let's try another one where the numerator is not 1, because I want to make sure that we put all of the steps together now. Okay? Whoa. All right, so our race is still 240 miles long, but this time I am going to go 5/8 of the way. I'm going to go 5/8 of the 240 miles. So I want you predicting right now, will my product be greater than or less than 240? Make sure you think about that. All right, so We have our fraction bar representing our whole. The whole entire thing right now is 240. Okay, so when you're given a whole, think about that. It's 240. I know that I'm dealing with eighths, 8 equal parts. So I'm going to make sure that I represent that in my representation. And remember, we still want to be making as close to equal parts as possible in our representations. If it's not perfect, that's okay. But if you see something that's a little way off, make sure you fix it. I'm going to double check. 1, 2, 3, 4, 5, 6, 7, 8. All right. So I'm thinking to myself, if I have 240 miles and I split it into 8 equal parts, how much will each part equal? Or another way that we can think about it is if I have 8 parts, how much is each part worth? 8 groups of what will make 240? Okay? And so since you're fluent with your multiplication and division and thinking about using your basic math facts to help you solve, you know that each piece is going to be worth 30 miles. So 1/8 is 30, the next eighth is 30. So if I split this race into 8 equal parts, each piece is worth 30. And again, I always like to double check 30, 60, 90, 120, 150, 180, 210, 240. Okay, sometimes teachers have to stop and think too. All right, so I know what each eighth is worth. But did I go 1/8 of the way this time? Let's check back at our equation. 5/8 of 240. So 5/8 of 240, I'm going to make sure I circle that in my representation. 1, 2, 3, 4, 5. Is this 5/8? You can make your circle big too if you want, however you want to circle it. 1, 2, 3, 4, 5. So I circled the correct amount. 30, 60, 90, 120, 150. Did I do that right? 30, 60, 90, 120, 150. So how many miles have I completed if I've gone 5/8 of 240? I went from here to the end of 5/8, and the distance from here to here was 150. So I have gone 150 miles so far. And once again, the product is less than this factor. So I'm wondering if there's a rule you can come up with that happens every single time you do a fraction less than 1/2 times this factor. What can we say about the product? Okay, so if you're sticking with me with that, I know that when I multiply a number by a fraction less than 1/2, my product is less than that factor. But just be thinking about that. That's a whole other video. All right, so what we did each and every time is we took the whole number and we represented that with a fraction bar. Okay? Then we thought about the denominator and we said that we're going to split this race into however many equal parts the denominator is telling you you're going to need. So we split that up. We had determined what each piece was worth in terms of how many miles each piece would be worth. Then we had to think, how many of those pieces have we completed so far? We completed 5 out of 8, so we circled them and we figured out what that was equal to. Okay, so I just want to show you what's another thing that's happening while we're doing this, and then I'm going to give you some to try on your own. So what you actually are doing is you are taking 240 and you divided it by 8 and you got 30. This is for friends who are ready to be thinking about what's actually going on. Then you said, so 240 divided by 8, then you said, I have 30 miles. Sorry, I have 5 groups of those 30 miles. and that is 150 miles. And that was what was happening in our fraction bar representation. We split it up into 8 equal parts. Split into 8 equal parts. We said each one would be worth 30. That happened, remember? And then we said, I'm going to take 5 groups of those parts. And we did. And we got 150. Okay? So, are there more ways to tackle these problems when you're multiplying a fraction by a whole number? Yes. Is this the way that I want you to practice today? Yes. If you have other strategies, do I want you to show me? Yes. Okay, so be thinking about this, the fraction bars. Some of you are going to start coming up with mental strategies for solving because you're picturing these fraction bars in your head, so it's a good place to start with practicing. All right, so here's the problems that I want you to try on your own. You're going to make a fraction bar, you're going to split it up into the correct number of equal pieces, and you are going to find how many miles you've biked if you've gone this far. Okay? So, I would like you to start with 1/3 of, let's do 1/3 of 180. So your bike race is 180 miles long, you've biked 1/3 of that distance so far. And I want you to double check your product. You're multiplying by a fraction less than a whole. So, did you go the whole entire bike race? No. Since you only did 1/3 of it, you should be thinking about your product being less than this factor. Okay, side note, sorry. I can't let it go because it's so important. All right, next one I want you to think about is I want you to take 3/4 of a race that is 480 miles long. So what is 3/4 of 480? So the bike race is 480 miles long, and I want you to pretend you've gone 3/4 of the way. Again, have you gone an entire one group of 480? All right, and then the last one I want you to do, let's think about sixths, and let's go 2/6 of 360. Okay, so you have a bike race that's 360 miles long. You've gone 2/6 of the way. Okay, give it a try. Represent the whole with the fraction bar. Split it up by the denominator. Take how many pieces that you need of it. Okay, 480, make the whole. Split it into 4 equal pieces. Figure out how many of those pieces you've traveled so far. Same thing down here. Okay, if you have any questions, please reach out. Bye.